Greetings. Today we're going to take a look at arithmetic sequences and partial sums. So a sequence is arithmetic if the differences between consecutive terms are the same. So here's a sequence, first term, second, third, fourth, and so on. Here's some other term, a sub n, and then there can be more than that, a sub n plus 1, a sub n plus 2, and so on. And it could be infinite. This is arithmetic if there is a number d so that the second term minus the first term is the same as the third term minus the second term, and that number is called the common difference. You can also see this as adding or subtracting from the first term to the second term, adding or subtracting some number to get that one, and it's always the same number, which is why they call it a common difference. So there are some good things to take a look at. Let's put it over here. Page 651 is what we looked at. And remember, d can be positive or negative. And any of these, subtracting any of these, a later term minus the one in front of it. So a sub 7 minus a sub 6. I bet that is. It is. So you can just subtract those and calculate what the difference is. On page 652, there's an interesting study tip that helps you figure out how to remember this formula. And this formula is for the nth term. So for any term in an arithmetic sequence, you can find that term if you know the first term and you know the common difference. So a sub n is a sub 1 plus the quantity n minus 1 times d. Let's find the nth term of an arithmetic sequence. And again, remember, this is only good for arithmetic. We'll also look at geometric ones later. Find the nth term of an arithmetic sequence with a common difference of 5 and a sub 1 equals 9. So here's our formula. A sub n is a sub 1 plus n minus 1 times d. We're going to substitute in the common difference of 5, and the first term is 9. And we're going to distribute this and simplify. So a sub n is 5n plus 4. So it's just a formula for any term in that sequence. Let's take a look at the next one. In this example, we're going to find the nth term of an arithmetic sequence, and we're given that a sub 5 is 19 and a sub 9 is 27. So when we have this a sub 5 is 19, that means we're letting n be 5. And here we're letting n be 9. So first, let's use a sub n equals a sub 1 plus n minus 1, that quantity, times d. First of all, let's find d. So in our first use of the formula, we're letting n be 9. If we do that, then n minus 1 is 8. So I've got 27 equals a sub 1 plus 8d. In the next time, in the next equation, I'm going to let n be 5. So a sub 5 is 19, because we're given that up here, is a sub 1 plus n minus 1 is 4d. So here's our n minus 1 is 4. So we're writing that formula down, and I'm going to take these two equations and I'm going to subtract them from each other because I can do an elimination of the a sub 1's. So then I've got 8 equals 4d, and I can solve for d, it's 2. Now we're going to use that d to actually find a sub 1 because we have two later terms and we'd like to know what a sub 1 is. So 27, so I'm just going to use this equation here, and I'm going to say that 27 is a sub 1 plus 8 times 2. So I'm taking the d that I found and substituting it into this equation. Now I can solve for a sub 1. It's 11. Now I can use the basic formula, and I'm going to substitute into it and find that a sub n is 11 plus n minus 1 times d being 2. Then I'm going to do what I did up here in the earlier example and distribute the 2 and simplify. Now I've got a formula for any term, so I could find the 157th term by substituting 157 in here and figuring out what it is with this formula. So these formulas are really useful for finding later terms in a sequence. There's another formula on page 654, and this is for the sum of a finite arithmetic sequence. We can only sum up a finite number of terms in an arithmetic sequence. We can actually find the sum of an infinite arithmetic sequence as well as a finite, I just said that wrong, sum of a finite, both a finite geometric and infinite geometric sequence, but we'll talk about that later. For arithmetic sequences, we can only find the sum of a finite number of terms. So S sub n is n over 2 times the quantity a sub 1 plus a sub n. And there's a really nice story in the book about this, so you might take a look at that. Let me continue talking about these examples. So we're going to find the sum of the first 15 terms of this sequence. The sum is S sub n equals n over 2 times a sub 1 plus a sub n. So this is the first term and the last term. If we want to find the sum of 15 terms, we're letting n be 15. So 15 over 2, my first term is 2, and what's my last term? Well, if I use that formula for a sub n is a sub 1 plus the quantity n minus 1 times d. I know a sub 1 right here was 2, and I can see that a sub 2 minus a sub 1 is 3. Do you see that I'm adding 3 each time to get the next term? That's my common difference. My n is 15, so n minus 1 is 14. I can simplify this. A sub 15 is 44. So I had to use my a sub n formula to figure out the 15th term. Once I found that, I could take that number and put it in here. A sub 15 needs to go right here. Then I'm going to simplify this and get 345. So that's the sum of the first 15 terms in this sequence. This can be used for finding something like the seating capacity of an auditorium. Each row has 2 more seats than the preceding row, and the front row has 30 seats. There are 40 rows in all. So we want to sum up all of the seats. We're going to let n be 40 since there are 40 rows. So I'm putting n as 40 in here. So I need a sub 1, the front row has 30, and I need a sub 40 because n is 40 in this case. So I'm going to go back and use my a sub n formula with 40 in it. And we're adding 2 more seats each time. So my difference is 2. N is 40, so n minus 1 is 39. And the a sub 40 is going to have 108. So that's the last row has 108 seats. So first row is 30, last row is 108 when I have 40 rows. And my n is 40 here, so simplifying this, we get 2760 seats. Don't forget to label your word problems. Let's take a look. I've got one more here. Problem number 41 on page 657. Take a look at this one. A sub 1 is 15, and a sub n plus 1 is a sub n plus 4. So what is D? And here's your homework set right here. I hope this helps.